As I said, today we will start with second lesson on kinematics, and it is dealing with acceleration. So now, the very first thing that you have to keep in mind is that acceleration is a vector quantity. So the way that we assign acceleration, or we know that we are dealing with acceleration, is lowercase a with a little vector sign on the top. So the fact that acceleration is a vector means that in order to fully describe the acceleration, we need to talk about magnitude and direction. Only when we have both of them, then the acceleration is fully described. Now, you have seen on Science 10 that the velocity was the rate of change of displacement. So it is the change that the displacement is having at a certain time. Now, if you have a position time graph like the one that we have here on the board, and we will talk about graphs probably tomorrow, but just so that you are introduced to it, then you notice that at this part of the graph, so from 0 to 15 seconds, the object, doesn't matter what is the object, is starting from 0, 0 position, and then it is going at I believe is positive 12 meters on 15 seconds. So the rate of change that this object is obtaining based on the position time graph gives us the velocity of the object. So if we discuss further this particular graph, we can say that for the first part of the motion, the object is moving with a positive velocity. Velocity is increasing from 0 to a certain point. And then from 15 seconds to 25 seconds, the object is staying at the same position, is not moving. And then from 25 seconds to 35 seconds, the third part of the motion, the object is moving with a negative velocity. So you can say that the velocity here is positive, the velocity here is 0, and the velocity here in this part of the motion is negative. Now, we will not talk too much about the graphs because, as I said, we will discuss this on the other lessons, but on the other hand, what do we see on this graph is that the slope for the first part of the motion is a positive slope. The slope for the second part of the motion is 0 because it is a horizontal line, and the slope of the graph on for the third part of the motion is negative. And you see now the correlation that is between the slope and the velocity on position time graph. So when the Science 10 teacher have told you that the velocity is the rate of change of the displacement as a function of time, then this is what it means. So what we are doing is we are actually calculating the slope of the position time graph when we are calculating the velocity. This is the meaning of the rate of change. So you will see it even later on when you go to calculus that when we are talking about the rate of change is actually finding the slope of the graph. So the same as the velocity, acceleration is a rate as well. But now instead of the displacement time or the rate of change of displacement, acceleration is the rate of change of the velocity. So it is telling us how much the velocity is changing at a certain time. Okay, so it's the rate of change of the velocity. And then you may have seen this, but we still bring this into the problems here, that the acceleration is the rate of change of velocity over time. So if we elaborate this more, the rate of change, the delta, every time that you see delta is change. That means delta is always final minus initial. So V final minus V initial over the time that this is changing. Usually, since we start at 0, we just say T, but in general is T final minus T initial. So from this formula, what do we see is that if we just say here V final minus V initial over time, that this change is happening, from here we can generate that time is equal to V final minus V initial over acceleration. Or if we are looking for V final, what that will be, I want you to tell me. And if you are looking for V initial, what that will be, I want you to work on your notebook and tell me what it is. Yes, V final is acceleration times time plus V initial. Okay, and then, yeah, plus. And then V initial. Okay, thank you very much. So will be negative acceleration time plus V final. Okay, so an object can be increasing the final velocity, and then what we have is, or the expression that we use is that the object is accelerating. So final velocity is greater than initial velocity on this case. And if the object is slowing down, meaning that final velocity is lesser than the initial velocity, the expression that we use is decelerating. So if final velocity is lesser than initial velocity, then we are in the position of decelerating. When we have an object that is accelerating, we assign it with a positive. So we say positive 3.5. And if we have an object that is decelerating, we say that acceleration is negative. And this is the confusion that majority of the students in Physics 20, when they are introduced to this concept, have. Now, up to now, we have said that if it is going east, is positive, if it is going north, is positive, and if it is going south, is negative, and if it is going west, is negative. But now we are saying that no, for acceleration specifically, if the object is accelerating, then is positive, and if the object is decelerating, is negative. And this object may go in east direction, may go in north direction, may go in south direction, or may go in west direction. So you may have a case when the object is and I will just take those 4 axes, but then you can go with even somewhere in between. So you may have an object that is accelerating with a positive acceleration going into east, but you may have an object that is accelerating going into west. Okay, so you may have an object that is decelerating going into north, and you may have an object that is decelerating going into south. So when we are saying that the object is, the object is having a positive acceleration, that means that the final velocity is greater than initial velocity. In which direction is it going? Then we will define that. In which direction is it going? But when you see a question, and we will see the examples here, but when you see a question that they are stating that the object is accelerating in the south direction, that means that the acceleration itself is positive, but the direction in which is it going is south. And again, this emphasizes again the fact that it's very good if we use the northeast southwest axis instead of just positive and negative. Is it clear, guys? Questions if you have any. So again, the positive or the negative sign of the acceleration is referred to the accelerating or decelerating the object. The direction is something else. Okay, so let's see this example here now. An object traveling at 40 meters per second increases its speed, so increases its speed at 100 meters per second in 4 seconds. What is the acceleration of the object? Now, with kinematics equations, this is part of it. Kinematics equations, the strategy that you will use is very simple, guys. What you will do is you will say what is given, what they are asking for, what is the formula that relate all those. And on this case, what is given is that initial velocity is equal to 40 meters per second. Now, notice here that they are not stating in which direction, so they are going in the same direction. So if they are going east, then they are going east. If they are going north, then they are going north. If they are going 30 degrees north of west, then this is the direction. They are keeping the direction as the object is starting at 40 meters per second and it is ending at 100 meters per second. Okay, so on this case, we just ignore the fact that what is the direction that they are going, but we just state what is given. The final is 100 meters per second, and the time that this change is happening is 4.0 seconds. So this is what is given. And what they are asking for is acceleration. Okay? So now, again, as I said, always ask. Always go with what is given, what they are asking, what is the formula that relates it. I hope that you have your formula sheet in front of you, and then you are finding that the acceleration is the acceleration formula is the formula that we will use. V final minus V initial over time. Now, even from the problem, we know that the acceleration will be positive. So the object will be accelerating. How do we know this? The initial velocity is less than final velocity. But even the math is telling us this. 100 meters per second minus 40 meters per second divided by 4.0 seconds. So the acceleration will be what? Tell me in your, yes, it is 15 meters per second. And then over seconds. So again, what the acceleration is a positive one. Why? Because the final velocity is greater than initial velocity. And then the magnitude of it is 15. And the units for the acceleration are meters per second per second. Let's just talk a bit about this for 1 minute, because I noticed that even on the test that we did, some students were doing it excellent, but then when it comes to working with fractions, they have a difficulty. Let's work on this first. So what we will see now is meters per second, and then this is seconds. When you are, this is dividing fractions. When you are dividing fractions, what do? Is you save the first fraction and you convert dividing into multiplying and flip the second fraction, 1 over second. So now when you are multiplying two fractions, you multiply numerators and you multiply denominators. So this will be meters per second times seconds is second squared. So the units for the acceleration are meters per second squared. Often, especially at the beginning, you will see it at meters per second over seconds, because when you see it like this, that means that is the rate of change of velocity. But it's fine to write it meters per second squared. So it's amazing. But just keep in mind, guys, when you are working with fractions, even that they are not numbers, as you may have seen it in math, still there are the same rules as when you have numbers. So again, a review from like a bit of deviation of what we have in physics is that when you are working with fractions, please keep in mind, when you are multiplying, then you multiply numerators, multiply denominators. When you are dividing, you, what is that called? Kiss and flip. So you save the first, convert dividing into multiplying, and flip the second. Okay, and then work with the units. And then you have a multiplying, which is multiply numerators, multiply denominators. When you are adding and subtracting, you will find the common denominator. Okay, so let's take a look at this example now. An object is traveling, and this is a case where if they're not saying which units you have to express the answer, then you have the freedom to do that any way you want. An object is traveling 300 kilometers per hour and slows down to 40, not 400, 40 kilometers per hour in 5 minutes. So let's sort out what is given. What is given is that the initial velocity is 300 kilometers per hour. And again, when you see a question like this, the direction is not stated, in which direction is it going. That means that you will assume that they are moving on the same direction. So they're going either east or west, but the same direction, or 30 degrees south of east. whatever is the direction, but it is on the same direction. And then V final is equal to 40 kilometers per hour. And then time is 5 minutes. What they are looking for is acceleration. Now, the strategy that we follow for kinematics equations questions is we sort what is given, sort what they are asking for, and take a look at the formula sheet and then say, what is the formula that relates everything given and asking for? And in this case, it's kind of easy because we have the, which color should I do? We have the acceleration is a V final minus V initial over time. Now, V final is 40 kilometers per hour minus 300 kilometers per hour over time, that is 5 minutes. Since the problem is not asking us what units the acceleration should be, you feel free to leave it kilometers per hour per minute. But if that bothers you, then convert the minutes into hours, or kilometers per hour into seconds and minutes into seconds. We'll do both cases. Okay, so now when we are using our calculator, we are finding that acceleration is, please help me with that. You should have negative 52 kilometers per hour per minute. Do you have this number, guys? And again, as I said, since they are not stating at what units you are looking for to have the acceleration, you can leave it like this. It's fine. When they are not stating, you are okay. But let's do some work here and then convert the 300 kilometers per hour for 40 kilometers per hour and 5 minutes into meters per second and seconds, and then find the acceleration into meters per second squared. So we have 300 kilometers per hour first. Let's convert them into meters per second. So we'll start with what is given, converting first the kilometers into meters. And when we are converting, what we are doing is we are multiplying by a ratio of 1, expressed into different units. So this will be 1 kilometers. And on the top, we will have 1,000 meters because kilometers and kilometers are canceled out. And then we have, so now up to this point, the units will be meters per hours. Let's convert hours now into seconds. So in 1 hour, we have 3,600 seconds. So hours and hours are canceled out. And that means that at the end of this, what we will have as units are meters per second. And then what we do is we multiply whatever is in the numerator divided by whatever is in the denominator. So this will be 300 times 1,000 and over 3,600. And the units are meters per second. So now using your calculator, tell me what is this? 83.3 repeated meters per second. Let's move to the next given. So the final velocity was 40 kilometers per hour, if I'm not wrong. And then we'll do the same calculation. So 1 kilometer, 1,000 meters, kilometers and kilometers are canceled out, and then 1 hour over 3600 seconds. So hours and hours are canceled out. And then what we have is 40 times 1000 over 3600. And someone please give me the calculations. This, the units for this will be meters per second. And the final answer will be, guys, one good. So will be 11.1. Is it one repeated? I believe. Meters per second. Good. And then the last one will be converting minutes into seconds. So then we'll have 5 minutes. And then we multiply 1 minute in the bottom over 60 seconds in the top. So minutes and minutes are canceled out. 5 times 60 is equal to 300 seconds. Now that we have everything into meters per second and seconds, we can calculate the acceleration. So acceleration will be V final 11.1 meters per second minus V initial 83.3, they are repeating, over 300. And in your calculator, what is the acceleration now? You can leave it as what we have here, negative 52 kilometers per hour per minute, or you can go ahead and convert everything and has it as negative 0.24 meters per second squared. Questions? This example here. So an object is traveling 60 meters per second, accelerates just by this word here. What do we expect that this value 5.0 meters per second squared is? Positive or negative, guys? Okay, so it's positive. When you see that the word accelerates is on the question, then you know that this is, write on it, right, is a positive, okay? Meters per second squared. Great, excellent. If the final speed becomes 100 meters per second, how long was the object being accelerating? Okay, so let's sort now what, and I will ask you and you will answer me on the chat. What is V initial? What is V final? Because those are the quantities that you will discuss. What is time and what is acceleration? You let me know. What is V initial in your chat? What is the value of V initial? On chat, guys. 60, good. So 60 meters per second. What is the V final? 100, excellent. 100 meters per second. What is time? Unknown, not given. Excellent, good. And what is acceleration? It's positive though, positive 5.0 meters per second squared. Excellent. What is that formula that relates all those four quantities? Is the acceleration formula. Excellent. So it's V final minus V initial over time. You have two ways to solve this because what we have here as a known is time. You have two ways. You can use that relationship that we had on the first slide where we are saying that time is equal to V final minus a V initial over acceleration, or you can substitute whatever is given and then solve for what you are missing. So both ways are fine. I prefer to use the formula because I have the tendency to have the literal equation there and then substitute whatever and solve for the unknown, but both ways work exactly the same. So then what we will do here is time is equal to V final is 100 meters per second. I will write the units, but you don't have to. Minus initial is 60 meters per second over the acceleration being positive 5.0 meters per second squared. So 100 minus 40 minus 60 is 40 divide by 5 will be 8. So this will be 8.0. Why 8.0? Because we are considering the significant digits, which in this case is the lowest one is 2. So this is how the answer will be recorded. But let's take a look at the why are we ending up with seconds here? So this is seconds, but why are we ending up with seconds? So see what do we have. In the numerator, we have, again, this is fractions. Huh? In the numerator, we have meters per second. Divided by, in the denominator, we have meters per second squared. So we are dividing two fractions. Therefore, we save the first fraction, meters per second, convert dividing into multiplying, and flip the second one, second squared over meters. Okay, so now meters and meters are canceled because they are in the opposite places. And then seconds and square is canceled because when you see squared is second times second. So one of the seconds is gone. And then what you are left with are seconds. Is it clear, guys? Let's take a look at this example now. So we have an object that is traveling west at 40 meters per second, experiencing an acceleration of 5.0 meters per second east for 5 seconds. What is the resulting velocity? So what is this means what is final velocity? Okay, in your notebook, please sort out what is initial, what with the direction. So when you are writing them, please write them with the direction. So V initial is equal to 40 meters per second going west. And then V final is unknown. Okay, acceleration is positive 5.0 meters per second squared going east. Okay, and time is a scalar quantity of 5.0 seconds. How are you going to do this? I want to see the answers. Leave you 5 minutes and then see the answers on the chat. Okay, so now we have to talk about that is known as the acceleration due to gravity. The acceleration due to gravity in general is known with letter G. So acceleration due to gravity is with letter G. Same, it's unique. It has its own letter because it is unique. It is no matter what you are feeling it, you are experiencing it. If you are at a certain height, that 9.81 meters per second squared that we have used when we are calculating the let's say potential energy of an object is there. It is a vector quantity, means that has a magnitude and it has a direction, because this is what a vector quantity has. But the uniqueness of this is that the magnitude near the surface of the Earth is 9.81 meters per second squared, and the direction is always going down toward the center of the Earth. So the uniqueness of the acceleration due to gravity for Earth is that it has those two specific values. So you don't have to calculate them unless you are doing a lab in which you are calculating the acceleration due to gravity in our case, Calgary. But if the question is telling you, is saying to you that what is, or an object is thrown from a certain height, blah, 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 and then what do you have to do, even though that it is not stated, you have to take it as a granted that the acceleration due to gravity at the surface of the Earth is 9.81 meters per second squared, and it's always going down. So vector that represent the acceleration due to gravity will be a vector that is always toward the center of the Earth, 9.81 meters per second squared. But each planet has its own acceleration due to gravity. And as a fact is that the further away from the surface of the Earth you go, the lower acceleration due to gravity is. So each planet has its own specific value, magnitude of the acceleration due to gravity. For Earth, as I said, is 9.81 meters per second squared. For Moon, let's say, is about 1/6 of this. So 1/6 of G is at Moon, at our Moon. Other planets has it higher, some has it lower. Let's take a look at this question that we have here. On planet X, an object is dropped from rest, and it takes 5.6 seconds to reach a velocity of 20 meters per second down. What is the acceleration due to gravity for this particular planet? So what is given here is that the initial velocity is equal to 0. How do we know? It's the word rest that gives us the clue that the velocity is equal to 0. When you have rest, is velocity equal to 0. When you have that the object stops, then that means that the final velocity is equal to 0. In this case, the initial velocity is equal to 0. Final velocity is equal to 20 meters per second going down, which is on the same direction as the acceleration. Time is 5.6 seconds, and what they are looking for is that G of that planet X. You can write it as a vector or not, because now everything is going in the down direction. So if we draw the vector diagram, what we will have here is that the initial velocity, the start point is here, and then it takes, this is the end point. So the velocity at this is equal to 0. The initial velocity is equal to 0, and final velocity is going down, 20 meters per second going down. And the time that this is happening is 5.6 seconds. So this will be, that is known as the situational diagram. Since everything is going down, because even the acceleration due to gravity of any planet is going down, you can ignore the sign or you can keep it, whatever you prefer. So acceleration due to gravity of this planet is calculated using the same formula as the acceleration is. So it will be V final minus V initial over time. And the acceleration at planet X will be 20 minus 0 over 5.6. And the units are correct because they are all meters per second and seconds. So 20 divided by 5.6 will be equals to 3 the acceleration due to gravity at planet X will be 3 the calculator gives you 3.5714 and so on. Since we have 2 sigdigs to write the answer, then we will go 3.6 meters per second squared. And this will be the magnitude. If we are fully describing it as a vector, then we will say the acceleration due to gravity at planet X is 3.6 meters per second squared going down. Questions? Okay, so let's go over this example now. How fast will the object be traveling after falling for 6 seconds? Without any other information, you must assume, and this is on the question, but usually it's on the example, but usually it's not on the question. Without any further information, the assumption that you will do is that the object starts from rest and it is dropped on the surface of the Earth. Okay, so now let's sort what is given and sort what they are asking for. How fast is it traveling? So what are they asking for? Velocity. They are asking for final velocity. So final velocity is question mark. Now, since everything is going in one direction, we can ignore the sign, or we can ignore. We see now that everything is dropped at a certain height, and then it is going down. What is final velocity after 6 seconds? Okay, so what is initial velocity? 0. Excellent. And time is 6.0 seconds. Now, it is not given here, it is not stated on the question that the acceleration is 9.81 meters per second squared, but since we are assuming that is nearby the surface of the Earth, then we can say that the acceleration, let's do this. Then we can say that the acceleration is equal to the acceleration due to gravity, which is equal to 9.81 meters per second squared going down. And now, again, the strategy that we use is we see what is given, we see what they are asking for, and then we take a look at the formula and see what is the formula that connects, relates everything in the question. So the formula, sure enough, is V final minus V initial over time. So 9.81 meters per second squared going down. And again, as I said, like, since everything is going in one direction, we can ignore it. V final over 6.0. From here, we find that V final is equal to, what is 9.81 times 6 is 50. This is what calculator gives you. 86 meters per second. And now we know that it's going down. Okay, we know that it's going down. But what is the correct sigdigs that we have to record the answers? Great, excellent. So then this will be V final equals to 59 meters per second going down. Questions, concerns? Let's take a look at the other example. So we have, if a ball is thrown up in the air at 15 meters per second, how long will it take to reach its maximum height? And then in addition, what is the total time that the ball is in the air? But let's do the first one. Let's do the first example, or the first part of the problem, not the first example. Okay, let's start by sorting what is it given. So initial velocity is 15 meters per second. In which direction, up or down? In the, okay, so it is up. Okay, and now when we see that, and we will talk deeply when we go to projectile motion on those kind of things, but you know, when we see that the object is reaching the maximum height, that means that the object doesn't have any more speed on that direction, any more velocity on that direction. Doesn't have any more. So that means that at maximum height, the velocity is equal to 0. Okay, so if you are stopping, then velocity is equal to 0. If you are going up and you are reaching the maximum, the velocity is equal to 0. Okay, so this is what do you have to keep in mind when you see this expression. The maximum height means translated into final velocity is equal to 0. And now, since we are at the surface of the Earth, this is what we are assuming here, the acceleration will be equals to the acceleration due to gravity, that is 9.81 meters per second squared going down. And what we are looking is time. Okay, in your notebook, please figure out what is the time that the object will be reaching the maximum height. So the acceleration will be negative 9.81 because it's going down, is equal to V final, which is 0, minus V initial, which is 15 up, positive, over time. From here, we find that time is equal to negative V initial, negative positive 15, over negative 9.81. And just a clue, guys, time cannot be negative. So it's 1.53 seconds. And this is the time that the object reaches the maximum. Now, when we are talking, in addition, what is the total time that the object is in the air, the same time that the object is going up, it needs to go down. And again, here is the assumption that we are throwing it from, we are throwing it from the ground. Okay, so a ball is thrown up in the air at 15 meters per second. Now, the assumption here is that the object is thrown from the ground. So the total time will be twice the time that the maximum is reached. So it will be 2 times 1.53 seconds. Therefore, the total time is 3.06 seconds. Do you have any questions, guys? If you have any, please let me know in the chat. Okay, so now I will leave you for, let's say, 15-20 minutes. You can work on those practice problems here. And the answers, as always, are on the brackets. So whatever you see in brackets is the answer. Work on those questions, and I will get back to you in 10 or 15 or 20 minutes. Depends on how you are doing.